Yeah, the official title of my presentation is the sensor-based lens selection process supported by a dedicated lens selection tool. Let me introduce myself. So my name is Steffen Mahler. I'm working as a product manager in the industrial business unit at Schneider-Kreuznach. I'm with Schneider-Kreuznach already since 1989, so it's already a few years. So our company is also fairly old. We have 111 years of experience in optical design and manufacturing. We are headquartered in Bad Kreuznach and have worldwide offices in the US and in Asia. What we are doing are optics, optical systems, mechanics, and optomechanical subsystems, both standard products and also customized development. So let's concentrate now on the topic of the speech. What is a typical lens selection process if somebody wants to design a complete vision system? From our experience, we know that vision system designers are very often no optical experts. And we all know how we are. What we don't know, we typically save for last. So we choose camera, we choose software, we choose lighting. And at the last point, we think, oh, we also need a lens. How should I get a lens now? And that's a very important and very difficult question for somebody to answer. So the good part is that there are lens selection tools available. Most of the well-established lens manufacturers, they offer a tool typically on their website, which helps choosing the right lens for the application. We have to differentiate here between portfolio filter tools and lens calculation tools. So what is the difference? Portfolio filter tool, as it says, filters the portfolio. So you enter typically some sensor information and at least the camera mount information. And this tool filters the product range and only shows the products which fulfill the input parameters. But, and that's very important, these tools don't do any calculation. So there is no focal length calculated. And here you see this because you don't enter any application information. And there are the lens calculation tools. Of course, again, you enter sensor information, camera information, but you also enter information about your application. And this is typically a working distance or a distance from the object to the sensor. And you enter information about your object, either the size of the object, which is mainly the case in industrial applications, or in some cases also the angle of view. And if you do this, there is some calculation behind, and there is a focal length calculated, which fulfills the requirements for working distance and object distance. So you can be sure that your object is imaged onto the sensor. This is just an example. This is a tool from our website. But as I said, most of the established lens manufacturers, they offer similar tools. And what can you do here? Typically, everything starts with the sensor. Most of the cases, a sensor is already defined, a camera is chosen, so we know the sensor model, the sensor size, and the sensor resolution. The sensor size is important because the lens requires an image circle at least as large as the diagonal of the sensor. And the pixel size information is important so that we know how the resolution of the lens needs to be. So what can you enter in such a tool? Typically, you can choose a sensor. Typically, you can input a working distance, and you can input information about the object. For this example, object width and object height. And here we have chosen some very typical values. The well-known IMX 530 Sony sensor, a working distance of 500 millimeter, very typical in industrial applications, and an object width and height. In this case, object width and height, the ratio is not the same as the sensor ratio, but the small calculation that, does consider this and makes sure that the complete object can be imaged on the sensor. And what you get as a result is a calculated focal length and a choice of different lenses that are quite close to this focal length. So we have calculated 17.6, and in our case, it would offer lenses with 16 millimeter focal length, 17 millimeter focal length, and 20 millimeter focal length. And it will only propose lenses with an image circle not large enough to the sensor. So you get a first hint of lenses that you may choose for your application. You can think, okay, I take the first one, I put it on my camera, and I have the best solution. Unfortunately, this is not the case, not with our calculator and not with all others. Because there are a few more parameters which are influencing the choice of the lens. These are, most of them, which are really important. So we have spoken about the sensor size, object size, magnification, working distance, mechanical interface. These parameters are typically considered for all lens calculators, but there are also others like pixel size, resolution. Some of them choose the lens according to the required resolution, some they don't. The spectral range is important. We have heard it in the talks before. You need special lenses for special spectral ranges. Some of the tools ask for that, some they don't. With lens type, I mean, you may need a zoom lens, you may need a telecentric lens. These are things that are typically not requested for such a tool. Things like light efficiency. If you have a low light application, you may need a lens with a very low f number. Also, this is typically not questioned. So these are parameters. Sometimes they are considered, sometimes they are not. And there are many parameters which are not considered at all in such typical lens selection tools. And these are specific imaging characteristics of a lens, like what you see, what you can read: distortion, transmission, vignetting. The sensor angular sensitivity is very important. I will talk about this in detail a little bit later. And also other things which are not really imaging performance, but other parameters which are also important for your application and where you have to think about size and weight. If you have a robotic application or UAV application, as the colleague from Edmund said, you have to look for size and weight. Mechanical stability is very important. And not technically at all, things like availability and cost. So you can use this page like a checklist, what you should consider when you choose your lens. Not only the first result out of a lens selector, but much more to make sure that you get the best possible lens for your application. This sums it up. And so we need to look closer into some parameters. I could talk about everyone for hours, definitely, but let's concentrate on a few of them. One example is object distance. If you look at the specification of standard C-mount lenses, and it typically says working distance range from infinity to 200 millimeter, from infinity to 100 millimeter. So you may assume that the lens works well in this full range. Typically, it's not the case. You can design lenses that do this job, but this is very complicated, very, very expensive, and most of the lenses, they do certain compromises. You can set them to infinity and focus them to infinity. You can focus them to 200 or 100 millimeter, but you may not get the same performance in all distances. And I show you here a very short example. The colored curves that you see here are MTF curves. You don't need to understand now what it really means. The basic information is the higher the lines, the better it is. The straighter the lines from left to right, from the center of the sensor to the edge of the sensor, the better it is. And on the left side, you see the lens performance, the MTF performance for working distance of 500 millimeter. This is an example of our Jade 25 millimeter lens. And you see it has a high performance and it has an even performance from center to edge. This is a lens series which is designed for typical machine vision applications in distances from, let's say, 300 to 1500 millimeters. There they are optimized. They can focus also to infinity, and you can use them in infinity. But if you do this, you will see the performance on the right side. So in the center of the image, the performance is still quite well, but you have a certain drop towards the edges. And this is something that, in my opinion, none of the lens selection tools from the optical manufacturers will tell you. So don't fully rely on the results that you get there. You have to ask yourself, do I need more information in order to do a better choice? And the answer will be yes. Second thing is, and this is something that also was discussed in the two speeches before, spectral range and MTF. The left side shows the performance in the visible spectrum. It's the same MTF as the page before. And on the right side, it shows the performance on visible and NIR spectrum. So it's a wider spectrum. The lens is not optimized for that. So the lens performance is also dropping down. Something that you should keep in mind if you use such a lens selection tool. There might be more information needed. And the third example that I will show here, this is the sensor angular sensitivity. All of the modern sensors are equipped with micro lenses on the pixels, which concentrate the incoming light onto the light sensitive surface of the pixel. This is a great idea in order to increase the efficiency of the sensor. The problem is that under certain angles, it can be that the incoming light is not focused on the light sensitive area of the pixel, but on the edge of the pixel. So, and this will affect in dark corners, as you see in the examples of the corrected lens and the uncorrected lens. Especially the second Sony Preachers generation was very, very sensitive here. And many of the lenses on the market has shown these shading effects with these kind of sensors. So there's also something that is not considered in any of the lens calculation tools. So the question is, what can you do? Because at that moment, you don't have more information about the pre-selected lenses. But there is one thing that you really can do and that we recommend to do. The lens manufacturers typically also show data sheets of their lenses on the website. This is an example of our data sheet. In this case, it's a 6-page data sheet showing very detailed many lens parameters, lens characteristics, lens data of the specific lens. You see the MTF, not only from 1 magnification, but for 3 magnifications, 3 F numbers. You see the vignetting, distortion, transmission. You see the mechanical data. You have, of course, a table with all the parameters, also like the weight and minimum object distance, things like this. So the data sheet shows much more information than you can get from a lens selection tool. And I really recommend you can use a lens selection tool as a first pre-selection, but then try to get more information about a few pre-selected lenses so that you really can decide what is the best lens for my application. So what is a typical lens selection process as we recommended? The first point, don't save the lens for last. When you are designing a vision system, try to consider all components in parallel, meaning a camera, an illumination, and a lens as the, let's say, physics parameters. Software is another story. Consider them really as a package and try to choose them at the same time, weight everything, every parameter together, and don't leave the lens for last. If you're not an optical expert, you can of course use the lens selector or the lens calculator, which is offered by the lens manufacturer, in order to get the first pre-selection. At least you get a focal length or focal length range that you need for your application to fulfill the requirements for the object size and working distance. But after that, review the technical data sheets of the pre-selected lenses, and you will see the one is performing better here, the other one is performing better there, and you can make your final choice, what will be the best lens for your application. Of course, I said, most of the vision engineers are no optical experts. So if you think that you can't manage to do this by your own, you always can contact the experts. And if our OptoCAD is not available, our technical salespeople will definitely help you. So if you're not sure, call us. We will discuss your application, and we will definitely find the best lens for your application. And that's it for now. I hope I could give you a little bit insight how to choose a lens for your application and where are the limits of, let's say, typical lens selection tools that you can find on the website. Thank you very much.
Thank you, Steffen, for your presentation. First question. How long will it take for AI to complete your lens selection tool with all the lens-specific data from the data sheet so that I can start planning my pension?
I'm a nearly 60-year-old guy. I don't know what AI means. No, this is of course a joke, but this is a question which I cannot answer. But definitely it's worth thinking how we can use AI to improve the tools for lens selection. Konrad, this is definitely a very, very good input. It's something we need to think about. The problem is that, let's say, most of the optical manufacturers are no software experts. So, but we can discuss this with partners. So this is a very good hint.
Is the Schneider lens selection tool also available as an offline version?
Unfortunately not. Up to now, it's only available on our website. Most of the tools, also from the others. There's one exception, and Arthur, you know this very well. This is the Machvis tool from Keyoptic, which is also very good software. And this one is also available as an offline tool. This is something that I know.
Mm-hmm. And does it make sense to compare data sheets from different manufacturers?
Ha! That's a critical point. Fortunately, there are some manufacturers who really show quite good data sheets, like also Linus Keyoptic does, but it is risky. There are some parameters where you can do it quite well, like transmission or distortion or things like that. But for instance, MTF, it's already quite difficult because you need to understand the circumstances for which the MTF is calculated. For instance, for which spectral range, for which spectral rating, for which F number, for which distance. And our experience is that in many data sheets from other companies, these parameters are not given. And if they are not given, you are comparing apples with, you are not comparing apples with apples, but you compare data based on different parameters. And so, in fact, they are uncomparable.
Mm-hmm. The calculation of the tool is based on simple optical rules, you said. How can I calculate the exact dimensions once I have chosen the lens?
Yeah, it's only a rough calculation. You can choose the lens parameters as given in our data sheets. like the exact values of the focal length, like position of entrance pupil, of nodal points and things like this. You need to be an, let's say, optical expert to do these calculations. We have internally an Excel tool which does this job. And if somebody really needs this information, we can also send on request this Excel tool.